The classical method is a subset of the subjective method. The classical method basically says, as we discussed already, if you have n possible outcomes, and f of those satisfy some criterion, then the estimated probability is just f over n. So if f is, the getting an even number on a six-sided die, there are three possible outcomes that satisfy that, right? 2, 4, and 6. And n is 6. There are 6 possible counts. So this is the classical method, and it relies on the assumption of equally likely outcomes. And really, if that's true, then you've already made a judgment call, which means this is also a subjective measure. But in this context, too, subjective is extreme in the sense that it can be pretty much anything. You can choose and assign whatever kind of probability you want to an outcome. Of course, you still have to make sure that the probabilities themselves are internally consistent, which is not always true. The other method is what we talked about when we were rolling a die again and again and again and again and again towards convergence, and that's the relative frequency method. So when you calculate the proportion of sixes and decide that that's the probability. So this again is our example first, and now we're getting into the poker example. So if we use this approach, the classical method to estimating the probability of, let's start with the royal, straight, flush, and spades. The first thing we need is what? Well, first of all, let's talk about what a royal, straight, flush, and spades is. It is the highest single hand in poker. It is the 10, jack, queen, king, and ace of spades. So how many such hands are there in poker? In poker? There's only one.
Yeah.
Royal, straight, flush, in spades.
Oh.
There's just one. So in order for us to calculate the probability of getting a royal, straight, flush, and spades, what do we need? If every hand is equal to 1, we have 1 over what?
52.
So you're telling me that the probability of getting a
No.
royal, straight, flush, and spades is 1 over 52?
Combination of 5 out of 52.
Exactly. Right? Because you don't care about order. It doesn't matter when you got the card, as long as you got the card on your hand. So what is this equal to? Well, it is a large number. 52 times 51 times 50 times 49 times 48 times 47 factorial divided by 5 factorial times 47 factorial. And these two cancel out immediately. And it turns out that when you do the math, or when you actually crunch the numbers, this is 2,598,960. If you cared about the order, you'd have something like 311 million different hands. But since we don't, there are only 2,598,960. Has anybody ever gotten a royal, straight, flush, and spades?
I saw someone get one once.
Okay.
I'd not be personally.
Interesting. Okay, so taking that one step further, what is the probability of just getting a royal, straight, flush when we don't care about the suit?
1/4 of that? 4 times that.
1/4?
4 times?
Or 4 times that. Right there, if you're just interested in the probability of a royal, straight, flush, still the count of the number of outcomes that satisfy this divided by n. So now you have 4 different ways you can do this divided by 52, choose 5. So let's make this a little more complicated. How about a 4 of a kind? How are we going to estimate the probability of that?
Look on the back of the poker card.
That's one approach. 13. There is, let's see, of suits, we've got clubs, diamonds, hearts, spades. So there are 13 suits. And king, queen, oops, ace, king, queen, jack, all the way down to 2. So there are 13 kinds.
Four suits?
Four suits.
Four suits.
Yes. There we go. Leaving us with 52 cards in all. So, probability of 4 of a kind.